Hello and welcome back. We're going to take a look at some Frayer models, and we're going to look at some situations where sometimes the exponent properties are put together. There's more than one property being used in a problem. So what we've done here is up top we have all of the properties that we've discussed so far, and they're all summarized with the rule in algebraic terms and then an actual example. So we have the product, the quotient, the power rule, the zero power, and negative exponents. So let's take a look at, so that's just a reference for you. Let's take a look at our first Frayer model. So the problem we're going to work on today is in the middle, and we're going to solve it and discuss it. So I would like to start with the expanded form. So I'd like to take all of our variables and expand them and see what it looks like. So when we do our expanded form, we're going to need a giant fraction bar, and we're going to go m to the third power. So that means m times n, so I'm expanding that, and then n to the fourth power. I'll change the color here. So times n, times n, times n, times n, because there's 4 of those. And then times 0 to the second power. So times 0 times 0, or O. I think it's an O, not a 0. Okay, let's expand it in the denominator. So beginning with our m's, m to the fourth power, m times m times m times m, looks like that if we expand it. And n, now notice it's just a plain old n. Okay, so that means there's just one of them. So we are allowed to put the invisible exponent in of 1. And sometimes that's helpful when we're doing the shortcut of the rule. Okay, moving on to our O's, there's 4 O's. O times O times O times O. Okay, so when we learned this property with division, we learned that we can cancel out or divide letters out. Like an m divided by an m is 1. So we can cross those out. M divided by m is 1. M divided by m is 1. Okay, so you can see we're left with 1m in the denominator. Let's move over to the n's. Looks like we can do 1 of the n divided by n's to get rid of it. And we can get rid of 2 sets of o's. O divided by o, which is 1, and o divided by o, which is 1. All right, so now let's look, what are we left with? So expanded form helps us to see clearly what we're left with. In the numerator, we are left with 3 n's, so n to the third power. And then in the denominator, I see 1m. So m, plain old m, or we could say m to the first power. And then how many o's do we have? We're left with 2 o's. So o to the second power. So that would be the final answer. Simplified. Okay, so expansion helps if you need to see it. You're not sure which rule to do. I really like expanding it. So what property is going on here? Since it's a division problem, you can see that we're going to be using the, if we look up top, we're going to use the quotient property, or the quotient rule. So we're going to put the name of the shortcut or the property here. So words to describe. Well, if we're going to use the quotient rule, we're going to keep the like bases. So we keep the same base. So keep the like bases and subtract the exponents. So that's our keywords when we're using the quotient rule. Let's move on to do simplest form. So let's try to use the rule, the shortcut to solve this. So remember, when we're dividing and the bases are the same, we keep the base and subtract the exponents. So we're going to do m, and we're going to do 3 minus 4. So we're going to do 3 minus 4. That's negative 1. Let's do our n's next. So we keep the base and subtract the exponents. So we're going to do 4 minus 1, which is 3 for the n's. And then we're going to do the o's. So we keep the base and subtract the exponents. 2 minus 4, which is negative 2. Okay, so this leads me to another property. Do you see the other property that's used here? Do you notice that we have right here some negative exponents? So that's another property that's used in this problem here. So it's the negative exponents. Okay, so to make a negative exponent a positive exponent, we rewrite it as a fraction. So what we're going to do is make a fraction. Now, n to the third was okay. So n to the third just stays in the numerator. And then to make the negative 1 a positive, right here, we're going to put it in the denominator and change it to a positive 1. And same with o to the negative 2, we put it in the denominator and change it to a positive 2. And then this would be our final answer, which is the same answer we got when we did the expansion way. So you could see these get a little tricky because we combine some of the properties and we have to deal with positives and negatives and doing some different properties here. But hopefully it starts to click for you when the rules get combined. Okay, so be sure your Frayer model is complete, and we're going to try the next one. Okay, so there's 2 more here. You're going to try the last one on your own, but I'll do this one with you guys. Let's start the same way that we just did. Let's start in this corner with expanded form. So what does this look like? Well, in parentheses, we have 4, and then we have p to the second power, so times p times 1q times 3 r's, r times r times r. So all of that is in parentheses, and then this 2 means that there's 2 groups of that. So I'm going to do the same thing again. 4 times p times q times r times r times r. Okay, so maybe you're writing a little smaller than me. I didn't mean to go over the box. Okay, so now let's put it all together. Okay, so we're going to start with our coefficients. Now remember, coefficients, we just do regular math with those. 4 times 4, which is 16. Okay, now the p's. How many p's do we have? 1, 2, 3, 4. So p to the 4th. And then q to the 2nd. And r to the 1, 2, 3, 4, 5, 6. R to the 6 would be our final answer. Okay, so if I did it the expansion way, I would just combine everything. But I notice what's happening here is the power rule. So this is power to a power, or the power rule. That means we can, if we did the shortcut, we would keep the base and multiply the exponents. So that's what we can put in the top corner. Keep the base, keep like bases, and multiply the exponents. Okay, so that's if we did the shortcut of the power rule. So let's do the shortcut. Now, if you're raising a power to a power, this 2 on the outside of the parentheses, the 2 gets distributed to everything in the parentheses. Everything in there. So beginning with the 4 to the second power, that means 4 times 4, which is 16. Then the p's, so p to the second raised to the second. We keep the base and multiply the exponents, like we said here. Then the q, there's 1 q right here, and 1 times 2 is 2. And then we do the r, and it's 3 times 2, which is 6. Okay, so did we get the same thing we did when we expanded? Yes. Okay, but we used the shortcut. Keep the base, multiply the exponents. So only one property in this one, but it was a lot of different variables, so it was a little bit harder. All right, now your job is to try to complete this one on your own. Try to expand it, try to figure out what the property, what the shortcut is, or the property rule. Try to describe the property. You can use the other side of the paper if you need help with that. And then give your simplest form final answer here.